Hello students, today we are going to see about the chapter solid state chemistry. Are you aware of it? Okay, let us discuss the structure, properties, characteristics and types of solid state. I am Dr. M. Sumithra, Assistant Professor, PG Department of Chemistry, Vellalar College for Women, Tindal. Let us go into the subject. Now, the concept of solid state lies in the heart of numerous scientific, technological and industrial advancement that shape our modern world. There are so many applications due to this topic, solid state chemistry. Enormous of applications have been happening under this solid state chemistry. All the matter around us, or maximum, it is only made up of solids. You know very well. There are three phases. Among the three phases, solid remains among the all is a major role in our world. From the microprocessor powering our computers to the materials revolutionizing renewable energy sources, solid state play a phenomenal role in day-to-day life. Actually, what is solid state chemistry? Solid state chemistry is a study of structure, properties and synthesis of solid materials, and it is also called as material chemistry. See the structures, how the crystal structures are defined, and it has been processed and it is explained why such a characteristics, how it happens. See the different structures of some of the compounds that have already found it. You know very well in your lower classes there are three states of matter. One is solid and another one is liquid and another one is gaseous form. The matter is made up of very small tiny particles, and these particles are very small in nature so that you cannot see in your naked eye. See, it is observed that matter exists in nature in different forms. Some substances are rigid and have fixed shape and nothing but it is called as a solid phase. And some substances flow and take the role of the container whatever you have, and it is called as a liquid phase. And some substances it will be along in the air, along as a vapor form, and that form it is called as a gaseous phase. You all are familiar about that. Now, so what do you know about matter? Matter consists of solid, liquid and gaseous phase. And further, among the three matters, solid, liquid and gaseous, solid seems to be the major portions in the earth. The solid has a greater investigations and scientific technologies has been gone through the solid phase rather than the liquid and gaseous phase, since because solid phase remains in the atmosphere remains in the earth in a long process. Now further, solid is being classified into two types, amorphous solids and crystalline solids. Later we will deal with what is amorphous and what is crystalline. And further, this crystallines are being classified into molecular solid, metallic solid, ionic solid and covalent solids. Now, so as I already said, solid is being classified into two types. One is crystalline solids and amorphous solids. What are crystalline solids? From the name itself, it is identified that crystalline solids are rigid in nature. They are rigid in nature. Usually solids are rigid in nature and they have a definite shape and they have a definite volume and they have good sharp melting and boiling points. Of course, we all know. Comparative with the liquids and gaseous phase. And solids, under solids, it is further classified into crystalline solids and amorphous solids. Coming to the crystalline solids, it is very rigid in nature. Why it is rigid in nature? And amorphous solids are powder in nature. And why it is powder in nature? They comes under the category of solids, but especially they have unique characteristics in their own way. And coming to the crystalline solids, and I have given the differences between the crystalline solids and amorphous solids so that you can easily understand what is exactly a crystalline solid meant and what is exactly an amorphous solid is meant. Okay. Coming to the crystalline solids, the internal arrangement of particles is regular. It is orderly arranged. The atoms that is present in a crystalline solids are orderly arranged in a order, in a line, in a row. It is arranged in such a way so that it does not go here and there. It is in an orderly arrangement. But in the case of amorphous solids, it is randomly arranged. That means it is not arranged in a straight. It is here, there, here one, here one. It is not properly arranged so that it is in a powdered form, or it is called as an amorphous form. Okay, they have sharp melting points because they are having the bonding between the atoms. It is very tight and they are having more amount of energy, and exactly you can show that exactly the point where it exactly meets because it is orderly arranged. It have a sharp melting points, but in the case of amorphous solids, they do not have a sharp melting points. And crystalline solids give a regular cut. Regular cut means if you want to cut in a correct shape and you can cut it with easily with any type of instrument, you can cut the crystalline solid. But in the case of amorphous, it is a randomly arranged. So even if you cut it, you will not get a proper design or a proper shape, whatever you want it. So you need a cut a crystalline solid. It is orderly arranged. The reason behind is why we can cut a crystalline solid orderly or in a nice shape, or in case of amorphous, we cannot cut the solid in a properly shape. Is the reason is it is orderly arranged. Atoms or molecules or ions, whatever it is in the crystalline solids, it is in orderly arranged manner, and in the case of amorphous solids, it is not orderly arranged. And coming to the next one, they have characteristics heat of fusion. What is heat of fusion? Is nothing but you are going to convert a solid into a liquid. The energy required to convert a solid into a liquid is called as a heat of fusion. Okay, so they have characteristic, proper, ordered, and a particular heat of fusion in case of crystalline solids, but in the case of amorphous, it has a irregularity. Due to the irregularity of atoms arrangement, it also has a irregularity in the heat of fusion. Crystalline solids are rigid and the shape is not distorted by mild distorting forces. You have to understand by mild distorting forces. That means an ordinary temperature, an ordinary pressure or ordinary catalyst. You cannot distort or you cannot disturb the shape of the crystalline solid using these factors. But in the case of amorphous, you can easily disturb it with the pressure or with a simple temperature or a simple catalyst. Easily you can disturb the structure of amorphous solids as it is not orderly arranged. Next one, crystalline solids are true solids because it is perfect. It is arranged properly and it is called as a true solids. But in the case of amorphous, since because it is not properly arranged, it is generally called as supercooled solids or pseudo solids, false solids. Okay. And last one, very important characteristics of crystalline solids is they are anisotropic. Anisotropic is such as the physical properties such as refractive index, conductivity, thermal expansion, etc. If you see that properties in all type of directions, it will not remain the same. So it will be a difference in that. But in this case of amorphous, the physical properties are same in all directions, and that property is called as an isotropic property. So these are the basic differences between the crystalline solids and amorphous solids. Okay, this is just a consigned of all the things whatever I said. So generally crystalline solids is a true solid, regular arrangement, sharp melting point, and isotropic character. Further, it has been classified into atomic solids, molecular solids, ionic solids, covalent solids, and metallic solids. Let us see what are these types of characteristics they have. Okay. Classification of solids, already it is crystalline solids and amorphous solids. Now coming to the category under the crystalline solids, atomic solids, molecular solids, ionic solids, covalent solids, and metallic solids. So based upon their forces, how they are classified. So main atomic solids, they have atoms. Molecular solids, they have polar or non-polar molecules in the crystal. Ionic solids, they have positive and negative ions in the crystal. Covalent atoms, they have a covalent bond network. They have covalent bonding between the atoms or ions, whatever it is. Inside the covalent atoms, you have a covalent bond network between them. And finally, metallic, they have the cations in the electron cloud. So these are the unit particles that is present in the particular crystal classifications. Coming to the binding forces, what binds them among the atoms? Among the atoms, atomic have atoms, I said. Among the atoms, which force binds them? Among the polar and non-polar molecules, which force makes them to bind together and have an orderly arrangement is nothing but, in case of atoms, it is London dispersion forces. In case of molecular crystals, it is van der Waals forces. In case of positive and negative ions, in case of ionic crystals, it is nothing but ionic bonds. In case of covalent bond, it is nothing but covalent bond. And in case of metallic bond, it is generally termed as metallic bonds. And coming to the properties, general properties, how an atomic crystal it will be soft, very low melting point, and in case of molecular, it will be very soft, low to moderately high melting point. They have poor thermal and electrical conductance. In case of ionic, hard, brittle, high melting points, high heat of fusion, poor thermal and electrical conductors. In case of covalent bonding, it will be very hard, very high melting point, poor thermal and electrical conductors. In case of metallic solids, you have soft to very hard, low to very high melting points, excellent thermal and electrical conduction, and it is malleable and ductile. Malleable and ductile is the properties of solids which can be converted into thin sheets and thin wires in case of solids. And coming to the examples of atomic, it's nothing but a noble gases. In case of molecular solids, it is a dry ice or solid methane. Ionic crystals, you have n number of applications of ionic crystals. It's nothing but NaCl where Na plus and Cl minus. Rock salt, it's nothing but rock salt where you have Na plus and Cl minus ions. And another one important property of ionic crystal is when it is in a solid state, it does not conduct electricity. Actually, ionic compounds, you have said they have electrical conductors. But in the case if it is a solid, if NaCl is in a solid form, it does not conduct electricity. Of course, I will give a real-time example. For example, if NaCl, what is NaCl? It is nothing but a common salt. When you have a common salt in your home, if you touch that common salt, do you get any electrical property in a common salt? You will not feel it. Right? You will take salt and put it in your curry and you will find it any electrical property? No, you will not find it because it is a neutral condition. Na plus and Cl minus together, they are in a neutral position. But in the case, what happens when it is dissolved in water, when NaCl or when a common salt is dissolved in water, it will be divided into or dissociated into ions as Na plus ions and Cl minus ions. Now what happens when Na plus and Cl ions, it gets charged, that compound gets a charge over there. So when charge is placed over the role, their electrical conductors plays a major role. So when it is in the solid state, it does not conduct electricity. Only when it is in a molten or in a liquid state, that ionic compounds, they have the electrical conductance. Okay. So here, so this is a structure of NaCl. See how it is being arranged. A simple cubic structure over here. So here it is, you will be having the structure. As I said before, they have high melting points. They do not electricity. So in case of solids, they do not electrical conductivity because they are having a fixed lattice positions and they don't move here and around. When they are in molten state, the ions move here and around, and hence you will be getting the conductivity. And when dissolved in water, they are free to move and they conduct electricity. This is an example for an ionic solids. And this is well example for covalent solids. Covalent solids, they have a higher network over here, and they have the they are usually poor thermal and electrical conductance. Why poor thermal and electrical conductance? Because they do not form any ions, they don't have any charges. That's why they have poor thermal and electrical conductors. Best example is a diamond. They had to have a covalent network. Does diamond conduct heat or diamond conduct electricity? No, not at all. Because it does not allow any electron flow inside the material. It does not have any vacant site for the electron flow inside the material. The same the carbon allotrope of diamond is graphite, but it conducts electricity. It is in the amorphous form. Why? Because the graphite, it has electrical conductivity because there is a movement of ions due to the vacant site that is present in the graphite. Here in diamond, you don't have any vacant site for the movement of electrons. So every atoms or molecules, whatever it is in the fixed positions. So movement isn't allowed. Hence there is not favorable for thermal or electrical conductance. And coming to this, molecular solids. Molecular solids, the constituents are neutral molecules, and further they are further classified into non-polar molecular solids and polar molecular solids, and finally hydrogen bonded molecular solids. Non-polar molecular solids. In non-polar molecular solids, they constitute molecules are held together by weak dispersion forces or London forces. They have low melting point and are usually in liquid and gaseous state at room temperature. Example, naphthalene, anthracene, etc. And polar molecular solids, these constitute are molecules formed by the polar covalent bonds. They are held together by relatively strong dipole-dipole interactions, and they will have higher melting points than the non-polar molecules. Example, solid carbon dioxide and solid ammonia, etc. And finally, hydrogen bonding molecular solids. The constituents are held together by hydrogen bonding, and they are generally soft solids under room temperature. Examples are solid ice and glucose, urea, etc. And this is an example, and where the cations and anions, they are having the hydrogen bonds. An example for hydrogen bonded molecular orbitals. Next, metallic solids. All the metals which are having such type of bonds, they are called as metallic bonds. Here the metallic bonds, the lattice points is nothing but the corner positions or the where the atoms or ions are placed. The lattice points are occupied by positive metal ions and the cloud of electrons pervades the space. So the major position, the cations, and around it the electrons are surrounded. They are hard and they have high melting point. Metallic solid possess excellent electrical thermal conductivity and they possess a bright lecture shining characteristics. And examples of metals and metal alloys belong to this type are copper, ferric, zinc, silver, gold, copper and zinc amalgam. All these things comes under the category of metallic solids. And coming to the basic, what happens? How you get the orderly arrangement? The orderly arrangement is caused only due to the unit cell. Unit cell is a repeated structure of a particular part. A particular part is being repeated. A smallest repeating unit of a crystalline lattice is a unit cell. The building block of a crystal building block, it is being repeated. It is being repeated. One cell you will have and it will be repeated again and again and again to form a bigger crystalline unit. Further, the unit cell is classified into three main types. One is primitive cubic unit cell, and second one is body centered cubic unit cell, and third one is face centered cubic cell. So what is primitive cubic cell? Only you have the atoms at the corners of the crystal lattice. You will have the atoms at the corners of the crystal lattice, then it is called as a primitive unit cell. What about the body centered cubic unit cell? In a body centered cubic unit cell, you have the atoms at the corners of the unit cell as well as the center of the crystal. In the cubic lattice, you have the atoms at the corners as well as in the, for example, see here, you will have atoms at the corners of the cubic cell as well as you will be having the atom at the center of the unit cell. In case of primitive, you will be having it only at the corners. And coming to the face centered cubic cell, you will have the atoms at the corners as well as in the face, each face. See, this is one face and you have a unit cell here over here, and this is one face and another is, you will have a atom over here. So you can see the atoms also in the faces of the unit cell. So these are the three types of unit cell: primitive cubic unit cell, body centered cubic unit cell, and face centered cubic cell. And coming to the applications of solid state chemistry, large amount of research has been being proposed on this case of solid state chemistry, and you type all type of p type semiconductors, n type semiconductors, all the junction boards, all the diodes, all the rectifiers, transistors, all these comes under the basic science that is solid state chemistry. So solid state materials form the basics of many areas of technology, modern science, ranging from long established materials such as glass, cements, to materials associated with the newer technologies such as advanced ceramics, optoelectronics, and thin film devices. And more than that, solid state have many practical applications in the field such as construction, medicine, electronics, engineering. For example, steel is commonly used in soil in construction, while silicon is used in metal implants. Now, I think you have understood the basics of solid state chemistry and what are the types and what are the structures, how it is being defined, the structures and the unit cell and its properties and its applications. We'll see in the next video how to have the other types of properties in solid state chemistry. Thank you very much for listening to me. Thank you.